C4H10. So isomerism is the compound with same molecular formula but different arrangement. Let's see C4H10 called as butane. Butane. So we may write it as a straight chain. That's CH3, CH2, CH2, and that's CH3. So C4H10. So, and you may write it as in this form. Now here you have the same molecular formula, that's C4H10, but they have different arrangement. This is called the linear structure, linear or straight chain. And what we called it as? It's branched branch chain. So these two are, and what will be its name? If you go for the name, it's called N-butane or the straight butane, straight chain butane, and that is called 2-methyl propane. So they have different names as well, but these two are isomers. Why they N-butane or the simple butane is the isomer of 2-methyl propane? Why? Just because
they have the same chemical formula.
Yeah, same molecular formula. That's right. So now we will move toward the types. What possible two types of isomers exist? That is, one is the structural isomer and other are the stereoisomers. So what they have the difference means, in the structural isomer we have three types. We have mostly we discussed the three types. Structural isomer, we have chain isomer, we have positional isomer, and we have functional isomer. Okay, in other types, we have stereoisomerism. In stereoisomerism, we have two types, that is geometric isomerism and optical isomerism. Okay, so moving toward chain isomerism, what we would have, like we have just studied that C4H10, it have two structure. One is straight chain and one is branched. 1, 2, 3, 4. And what's branch? 1, 2, 3, 4. So that is butane. Like keeping the constant, like they have the hydrogen, if you will count, it will be C4H10. The same here, that is butane, and this one is 2-methyl propane. Okay, now the positional. Move toward the positional. We have studied in the alkene, we have studied in the alcohol. Like you have like this. If you have like this, carbon on OH on first carbon and OH on the second carbon, you have the difference of the position. What will be the name of the first compound? It would be propane 1-ol, and it would be propane 2-ol. So propane 1-ol and propane 2-ol are the positional isomers of each other. Similarly, but 1-ene and but 2-ene, they are the which isomer of each other? But 1-ene
This is
or but 2-ene. They are the positional. Yeah. And in the functional isomer, interestingly, we have change of the functional group. How? Like if you have the formula C2H6O, you can have CH3, CH2OH. What its name? What is the name and what is its family or the functional group? Ethanol.
ethanol.
Okay. And if we go for, they also have the same formula. What its name?
This is
Ether, it's methoxy. We have just studied in previous lesson methoxymethane. So methoxymethane and ethanol are functional isomer of each other because they have the same molecular formula, that is C2H6. So you may count. Okay. And one more thing. Okay, that is it. So that these are the structural example of structural isomer. In chain isomer, we have difference in the chain. One would be the straight, one would be the branch. The main chain, one compound have the long chain and one have the smallest chain, but they have overall the molecular formula is chemical formula is same. Okay, now the other is positional isomer. What is the different? Position is the different. Position of functional group is the different. If you say like uh, chlor, one chloropropane and two chloropropane. So one chloropropane and two chloropropane are dash isomers of each other. They are the positional isomer because the position of chlorine is changing, right? Okay, any doubt, any question from the structural isomer? Stereoisomerism, we have a geometric isomerism, and their types are as cis and trans. So technically, cis is the symbol of or the synonym of, you may say that same, and trans that are the cross or opposite type, opposite or one-to-one type. Okay, though. So what we will study in the geometric isomer, that is if you have butene, okay, if you have butene, it could have two geometric isomer. How? Even butene could have two geometric isomer. Like if you are going to write formula for your convenience, it would be like this. So I am just writing this thing, and they would have one H and one H. So I am writing this part first. So C double bond C, they are connected with H and H. And one carbon of this CH is connected with H and one is connected with CH3. So if you are gonna see it in the form of butene, so have a look at this. It's a 4-carbon chain, okay? From 1, 2, 3, and 4 carbon. But we are explaining it in the term of geometric isomer. Either they have same branches on the same side, they have same type of branches. So the name appear will be cis butene. And if they have arrangement or orientation like this, orientation in such a way that the both come opposite to each other, like C double bond C, H comes above, CH3 comes below, and the second carbon do not have any changing. Now you see, you have the thing, not the similar things on the one end. So this will call trans. Now, what we will name is, that is transbutene. Okay, if you have a question, what are the possible isomers of C4H8 butene? So other than other than other than structural isomer, you are going to write geometric isomers as well in inclusion. Okay, these two will be the addition other than the structural. So they in the butene it have two kind of geometric isomer. Now some terms and conditions for the geometric isomer. Number one, it does not exist in alkane. It does not exist in alkanes. Why? Because they do not have the arrangement, specific arrangement. Okay, it not exist in alkyne, in triple bond compound, because they have linear shape. And for the alkane, you may learn that they have the rotation. Okay, so now the question is, does all alkene have geometric isomer? The answer is no. I repeat, does all alkene have geometric isomer? The answer is no, not all, only that, only those having different groups or substituent are it with any sp2 hybridized carbon. Sp2 hybridized carbon is a carbon which is connected with double bond over here. So the term is, if you have a long chain like this one, and you have two similar thing like this, no, this compound would not have the geometric isomerism. Why? Because this sp2 hybridized carbon is connected with two similar things, two similar groups, two similar substituents. I repeat, if any alkene, if it is connected with two similar type of reagents, then it would not have the geometric isomerism from that carbon. Okay, any doubt, any question?
Okay, sure.
Okay, now the second condition is, it must not have terminal double bond. No terminal double bond. If you have a terminal double bond, that is also the root of that above topic. No
So what's a terminal double
terminal,
bond?
like this one. This is terminal. If you have a double bond on a terminal position, either on the first carbon or on the last carbon, so it will not have, it would not have geometric isomerism. So no geometric isomerism, right? So these are, and the next thing is, you have studied in alkane, alkyne, and one other thing that has the, that is cycloalkane. Cycloalkane, they also have geometric isomerism. How? Now we have studied the understanding the skeletal form. So it is cis type, and this is trans. Okay, so what would be its possible name? No, we have understand that this is cis type because the same sides have the same kind of position, and it is cis. Its first carbon is second carbon, 1,2 dimethyl cyclopropane. Okay, 1,2 dimethyl cyclopropane, and the next one is trans 1,2 dimethyl cyclopropane, right? Any, any doubt? So optical isomerism exists in the compounds of alkenes. You may say that with they must have, in optical isomerism, they must have a chiral carbon. Now that's very simple, with chiral carbon. And what is chiral carbon? It must have 4 different groups attached to it. 4 different groups must be attached on the 4 sides. They must not be similar. Now, this carbon is called as chiral carbon. What is the identification of the chiral carbon? That it must have 4 different groups attached to any carbon. Then that carbon is a chiral carbon, and then the chemical would have optical isomerism. So I will just show you. So which carbon is a chiral carbon over here? This one.
And
Because
this side.
this carbon is, now we will, how we usually draw it like this. I have told you, you will write in one in the dotted form and one in the like. So what will be its optical isomer of it? They would have a mirror images. So it would have a rotation like COOH appearing over here and H coming there and NH2 over here. So these two are the optical isomer of each other with mirror images, right?
Yes.
So these were the just the intro notes for the isomerism so far.